Alright, so this is a problem set that you're going to be looking at, right? And so I'm going to be zooming in and out a bit just so that we can focus in on a few pieces. Alright, so I'm actually going to zoom in here, make this a little larger, and we'll kind of go from there. So one of the first things that we need to understand here is that the sum of the interior angles of a triangle, so sum of interior angles of a triangle equal 180 degrees, right? So we know that if I add up this, let me actually get a different marker here, one that actually will show up a little better. If I add this, and this, I'll get 180 degrees, right? So we know that based upon the rule. So because I know that, I'm now going to look here and see that I have 96 degrees for A, so this is 96 degrees. I have 42 degrees for B. Let me actually change the color there. So I've got 42 degrees for B, which means 96 plus 42 plus something right here, so some number right here should equal 180 degrees. Well, what that means for our situation right now is that we're going to take 180. I've got to find a marker that actually works. Black should do it. There we go. So there's 180. I'm going to subtract 96 and then subtract 42 because that is the measure of angle A minus the measure of angle B. Now the reason it works that way, so let me back it up just real quick here. Okay? The reason it works that way is because if I have the measure of angle A plus the measure of angle B plus the measure of angle C, that should equal 180 degrees. Well, I don't know the measure of angle C, so I'm going to subtract the measure of angle A and subtract the measure of angle B from both sides. And what that does is it leads us to the measure of angle C equaling 180 degrees minus the measure of angle A minus the measure of angle B. Well, what's the measure of angle A? It's 96 degrees. So I'm going to plug that in. 180 degrees minus 96 degrees. Minus, well, what's the measure of angle B? 42 degrees. 42 degrees. So if I do the math, which is just straight arithmetic here, I'm going to get 180 minus 96 minus 42, and that's going to give us 42 degrees, which is my answer here, is 42 degrees. Now, what's really great about this whole scenario here is the fact that these two angles are exactly the same, and these two angles are exactly the same. So that means this is also 42 degrees. Okay? Now, in your option for the next one, part B, you have a ruler. Okay? And that ruler, you basically just click so that you click a point here, and then you click the other point here, and you just see what the distance is, like 9 or 12 or whatever it says. Okay, so that's all you got to do for that part. And then what you'll do is you'll fill it in. So let's say it's 9 and 5 and 4 and 2 and 12 and 3 or something like that, right? So those will be the numbers. What we're going to do is we're going to take those numbers and apply them into C. So what I need to do is I'm going to zoom out here real fast, and we'll look into part C now. Okay? So part C is what's AB over DE? Well, it's simply 9/5, and there's nothing I need to simplify there. BC over EF is 4 over 2. Both of those are divisible by 2, which means my final answer here is just 2 over 1, right? Or just simply 2. For CA, it's 12 over 3. Both of those are divisible by 3. And 12 divided by 3 is 4, and 3 divided by 3 is 1, so my answer here is just 4. So now we're going to take all this information and we are going to apply it to these questions. Okay? So it says 3 pairs of statements are shown below. For each pair, select the true statement. The angles in triangle ABC have the same measures as the angles in triangle DEF. That is true, so we're going to pick that one. The ratios of corresponding side lengths are all equal to each other. Well, I look at this. This is 9/5, that's 2, that's 4. So no, they are not all corresponding. And we look at finally the last one, the triangles are similar, the triangles are not similar. Well, because the ratios are not all equal to each other, therefore they are not similar. Okay? In order for you to have a similar triangle, you have to have this being true and this being true. If both of those are true, then the triangles are similar. Okay? So that's how you solve this one. This is the same as problem number 7, I believe.